Welcome back, everyone. This is Uhfgood, and we are going through John Lemon Part 2, Player Character Part 2 tutorial, and we're learning to code in C Sharp. So let's continue on. Set the values for your variable. Now that you have a variable to store the movement for the character, you need to set the value for it. Since this could change every frame, you need to set it every frame. You should do this in the update method. In the update method, after the horizontal and vertical variables are created, add the following line. Okay, so here, let me shrink this back. Okay, hopefully we get to see something work here. M movement dot set horizontal 0f vertical. There. And let's save it. This. Okay. Vectors in 3D space. Let's see. Vectors in 3D space have three values. The set method assigns a value to each. It has three parameters, one for each coordinate of the vector. The movement vector now has a value of a horizontal input in the x-axis, 0 in the y-axis, and vertical input in the z-axis. There's also an f after the 0 for the second parameter, which is instructing the computer to treat that number as a float, or 0.0. Now you need to fix a small problem. The movement vector is made up of two numbers that can have a maximum value of 1. If they both have a value of 1, the length of the vector, known as its magnitude, will be greater than 1. This is a relation between sides of a triangle described by the Pythagoras theorem. This means that your character will move faster diagonally than it will along a single axis. In order to make sure this doesn't happen, you need to ensure the movement vector always has the same magnitude, and you can do this by normalizing it. Normalizing a vector means keeping the vector's direction the same, but changing its magnitude to 1. Add the following script beneath the previous line you wrote, and to call a method on the vector itself. Okay, so m movement dot normalize. There. Cool. And actually, you normalize it just magnitude of 1. It just means it sets whatever number it is into a value that fits in between 0 and 1, instead of going over it. And then so then it's just keeping its direction. So if you're moving like 0.001 on the x-axis and 0.1 on the y-axis, so that it's going, like kind of diagonally. Making sure that the number is normalized just means it still goes in that direction. That's still the relation between the the x and the y coordinate. Okay, so add the following script. Okay, full script should look like this, which it probably does. Player movement, vector 3 movement, start has nothing in it, update. The only reason that this is like on this second line is just because I don't have the thing out wide enough, otherwise it would look closer to that. Okay, movement, horizontal, movement set. So we're just setting, we're getting the axes, we're setting it, we're normalizing it so that it keeps the direction but doesn't move it. This example includes a gap between getting the input and setting the movement vector. This isn't important, it's just to make it appear tighter. Getting the input. Oh, I see. They put a space in between there. I guess I could do that too, just to make it like that. Okay, mark step as completed. Set up the animator component. Aha, now we get back into cases here. Now that you've created a movement vector, there are some other jobs that need to be done every frame. You need to instruct the computer to tell the animator component whether or not the character is walking. Get a rotation for the character from the player input, similar to the way you got its movement. Apply the movement and rotation to the character. Let's start with the animator component. Identify whether there is player input. If there's any player input, then your character should be walking. If there's not, then it be idle. Then it should be idle. To start off, you need to write a line of code that determines whether or not there's any horizontal input. Add the following code after the line normalizing the movement vector. Okay. Bool has horizontal input equals not, that exclamation out is not, logical negation, logical not. Okay. Math F, which is a library for floating point math. Approximately, I don't know what approximately is. It's its own. Whoa. What? What's dot approx. There, I had to hit the down arrow for it to actually work. Horizontal 0f. Okay, here you're creating a bool variable, one that can be either true or false, and calling it has horizontal input. Then you're setting the equal to the return value of a method. This method is called approximately and is from the mathf class. It takes two float parameters and returns a bool true if these two floats are approximately equal and false otherwise. So in this scenario, the method will return true if the horizontal variable is approximately 0. Interesting. I've never heard of approximately function, so it's something that maybe the Unity guys put in there. But wait, there's more. There's another character in this line you haven't encountered before, the exclamation mark in front of the method call. This is a logical negation operator, a logical not. Just like there's or, XOR, nor, anyways, logical operation. And inverts a bool, setting true to false and false to true. This means that has horizontal input is being set to true when horizontal is not approximately 0, equal to 0. In other words, has horizontal input is true when the horizontal is non-zero. Okay, it's just the horizontal axis that you care about though. Add a similar line for the vertical axis. Okay, so for the vertical axis, bool has vertical input equals not math f dot approximately vertical 0f. Okay. The line is doing exactly the same thing but for the vertical axis. Now that you know when you're getting input on the axes, you need to combine them into a single bool. Add the following line of code. Okay. Bool is walking equals has horizontal input or has vertical input. And that's just a logical OR operation. So logical not is the exclamation mark, logical OR is that, logical AND is 2 ampersands. The line is creating another new bool variable called is walking, which is set to has horizontal or vertical input. These two vertical lines are the logical OR operator. This compares the bool on each side. If either of them, both of them are true, then it equates to true, otherwise it equates to false. So that means if has horizontal input or has vertical input are true, then is walking is true, and otherwise it is false. So we are done with that step. Okay, create a variable to store a reference to the animator component. Next, you will need to tell the animator component whether or not the character should be walking using the bool you've just created. To do this, you need to access the animator component. But hold on, why do you need to do something special to access the animator component when you didn't need to do it to call the methods on input or mathf? This is due to the methods on input and mathf being static. Static methods are methods which are called on a class's type rather than an instance of that class. There is no need to have a single instance of the input class in order to determine access values because the input is more of a global concept. As such, the methods which obtain those values have been made static. Likewise, the mathf class is full of helper methods, methods which help another method perform its task, which don't involve any specific data for the specific instance of mathf. And so those methods have also been made static. However, consider your end movement variable. You needed to set values specific to that particular instance of vector 3, so these methods were not static. The important thing to remember is that the static methods are called using a type name and non-static methods. For instance, instance methods are called using an instance name. Okay then. Mark step is completed. Okay, so get a reference to the animator component. Okay, so what are we doing for time here? Okay, before you can access the animator component, you need to reference it, and this is obtained using a method called getComponent. This reference will be used throughout the class, not just in a single method. It makes sense to keep it as a member variable like the movement vector, so its scope is local to the class. Top of the class, above the movement vector declaration, but below the class declaration, add the following line. What did it say? It says above the movement vector declaration. Okay, so above that, we want to go animator m animator semicolon plus description. Now look like this, and it actually does. In this example, the comments above start and update methods have been removed. You can do this too if you like, but you don't need to. Comments don't affect the code in any way. Okay, work is completed. Okay, set up the reference to the animator component. You've created a variable to store a reference to the animator component, but so far you haven't set this variable to anything, and it's empty. When a variable is empty in this way in C#, it is said that its value is null. Whenever there could be a reference to something and there isn't one, the reference is null. You don't want a null reference here, so now you need to set up the reference properly. You also need to be able to access the animator component in any method, so it's important to set the reference as soon as possible. Okay, one of the earliest methods to be called on a mono behavior is the start method. You explored earlier in this tutorial, so it makes perfect sense to set up the reference there. Add the following line to the start method. Okay, so this one initially starts up, right? M animator equals get component. Okay, animator and parentheses, and we save it. And I say that's about it for this video. So, okay, so let's finish this off real. Set the. All right, you know what? We're gonna extend this out a little bit, a few minutes, and just so I can finish this off. Okay, the method should now look like this, which it does. The line of code uses some familiar and some new syntax. The variable you're assigning to is on the left, the name of the method is on the right, but it doesn't have anything written before it. There is a angle-shaped brackets around the animator before the parentheses that you have encountered before. The line ends with a semicolon. What does this reference mean? Let's explore your code. On second thought, I take that back. We'll finish this in the next video because it's going through and I have to explain and all that stuff. So thank you for watching, and I'll see you the next time.